In the vast expanse of our solar system there lies a moon that has captivated scientists and space enthusiasts alike. This celestial body, orbiting the ringed giant Saturn, is Titan. What makes Titan truly special is its eerie resemblance to our own planet. It possesses a dense atmosphere, a rarity in our solar system. But instead of rivers of water, Titan boasts rivers and lakes of liquid hydrocarbons. This makes Titan a world utterly alien, yet strangely familiar. Our journey to understand Titan began with Voyager's flybys, which offered us the first glimpses of this enigmatic world. However, it was the Cassini-Huygens mission that truly revolutionized our understanding. The Cassini orbiter and the Huygens probe, which landed on Titan's surface, unveiled a world of wonders. We discovered vast deserts sculpted by organic rain, towering mountains composed of water ice, and of course those sprawling lakes and seas of liquid methane. Titan, shrouded in a thick orange haze, remained an enigma for centuries. Early telescopic observations could only reveal a blurry sphere, its surface obscured from view. The Voyager spacecraft, in their fleeting flybys, managed to pierce this veil, providing the first tantalizing glimpses of Titan's surface. However, it was the arrival of the Cassini-Huygens mission in 2004 that truly unveiled Titan's secrets. The Cassini orbiter, equipped with a suite of advanced instruments, spent over a decade meticulously mapping Titan's surface and studying its atmosphere. The Huygens probe, in a historic first, descended through Titan's dense atmosphere, providing invaluable data and images of its surface. These combined efforts painted a picture of a world both alien and strangely familiar, a world sculpted by forces we are only beginning to comprehend. Imagine a world where rivers flow, not with water but with liquid methane. This is the reality of Titan, where temperatures plummet to minus 179 degrees Celsius, or minus 290 degrees Fahrenheit. At these frigid temperatures, methane, a gas on Earth, transitions into a liquid, forming vast lakes and seas across Titan's surface. But Titan's landscape is not just defined by its hydrocarbon lakes. Vast plains, sculpted by winds and methane rain, stretch across its surface. Towering mountains composed of water ice rise above the plains, their peaks shrouded in a perpetual haze. The Huygens probe, as it descended through Titan's atmosphere, captured images of riverbeds carved by flowing methane, hinting at a dynamic world shaped by erosion and precipitation. This alien landscape, painted in hues of orange and brown, offers a glimpse into a world governed by chemistry and physics vastly different from our own.
What truly sets Titan apart in our solar system is the presence of these sprawling bodies of liquid methane. These lakes and seas, some larger than Earth's Great Lakes, are not just static pools of hydrocarbons. They are dynamic environments, influenced by Titan's weather patterns and geological processes. Cassini's radar instruments, piercing through Titan's hazy atmosphere, were able to map these lakes and seas in detail. They revealed shorelines that ebb and flow, indicating the presence of tides or fluctuations in lake levels. Some lakes appear to be partially filled with evidence of past shorelines, suggesting changes in Titan's climate over time. These observations hint at a world that is far from static, a world where the landscape is constantly reshaped by the forces of nature.
Section 5. Waves on a methane sea clues from Cassini. While the existence of Titan's lakes was known, the possibility of waves on their surfaces remained a topic of debate. After all, the low gravity and the thickness of the liquid methane suggested that any waves would be minimal, barely noticeable. However, data from Cassini's radar altimeter provided the first clues. Slight variations in the reflected radar signals, when analyzed meticulously, hinted at the presence of surface undulations. These undulations, while tiny, measuring only a few centimeters in height, were nonetheless significant. They confirmed that even in the alien environment of Titan, with its dense atmosphere and exotic liquids, the forces of wind and pressure could still generate waves on the surface of its lakes and seas. Section 6. The Currents of Kraken Mare, Unraveling Titan's Mysteries. Kraken Mare, Titan's largest known sea, holds a particular fascination for scientists. This vast expanse of liquid methane, larger than Earth's Caspian Sea, is believed to be hundreds of meters deep in places. Analysis of Cassini data, particularly from its radar instrument, has revealed tantalizing evidence of currents within Kraken Mare. These currents, driven by winds and possibly influenced by Titan's tides, play a crucial role in mixing the sea's contents and transporting heat. Understanding these currents is crucial for unraveling Titan's methane cycle, a complex interplay of evaporation, precipitation, and subsurface flows that mirrors Earth's water cycle in many ways.
Section 7, Earth and Titan, a tale of two worlds, two liquids. Despite the vast differences in their environments, Earth and Titan share a surprising similarity, the presence of liquid on their surfaces. While Earth is awash in water, Titan's surface is sculpted by liquid methane. This stark contrast, however, highlights the fundamental principles that govern both worlds. Both Earth and Titan experience cycles of evaporation, condensation, and precipitation. On Earth, it's the water cycle. On Titan, it's the methane cycle. Both bodies have weather patterns driven by solar energy, although the specific mechanisms differ. By studying Titan's methane cycle and comparing it to Earth's water cycle, we can gain a deeper understanding of the fundamental processes that shape planetary environments.
Section 8. A climate shaped by methane. The forces driving Titan's lakes. Titan's climate is a fascinating enigma, intricately linked to its methane cycle. Unlike Earth, where water exists in 3 states, Titan's methane can transition between liquid, gas, and even solid forms depending on the conditions. The sun's energy, though weaker at Titan's distance, still drives this cycle. Methane evaporates from the lakes and seas, forming clouds in Titan's dense atmosphere. These methane clouds, unlike Earth's water vapor clouds, are not always visible. They often condense and precipitate back onto the surface as methane rain, replenishing the lakes and seas and continuing the cycle. This methane-driven climate has profound implications for Titan's geology, its atmosphere, and potentially even its habitability for certain forms of life.
Section 9, Dragonfly, exploring Titan's shores. To further unravel the mysteries of Titan's lakes and seas, NASA is sending a new mission to this enigmatic moon Dragonfly. This ambitious mission will deploy a rotorcraft lander on Titan's surface, capable of flying from one location to another. Dragonfly will explore Titan's atmosphere, its surface, and most importantly, its lakes and seas. It will study the composition of the liquid methane, analyze the sediments on the lake beds, and search for signs of past or present life. The mission will also investigate the complex organic chemistry occurring on Titan, which may hold clues to the early stages of life's development in our own solar system.
Section 10. Conclusion. Unlocking the secrets of a distant world. Titan's lakes and seas, filled with liquid methane, represent a unique and captivating phenomenon in our solar system. They offer a glimpse into an alien world shaped by forces both familiar and strange. By studying these lakes, we gain insights not only into Titan itself, but also into the fundamental processes that govern planetary bodies throughout the cosmos. The upcoming Dragonfly mission, with its ability to explore Titan's surface and its lakes in unprecedented detail, promises to revolutionize our understanding of this enigmatic world. As we peer through the hazy veil of Titan's atmosphere, we catch a glimmer of the vast unknown that lies beyond our own planet. Each discovery, each piece of data, brings us closer to unraveling the secrets of this distant world, and perhaps even to answering one of humanity's most profound questions. Are we alone in the universe?